Write the heading, please. Properties of vectors. Written. So some important properties of vectors are, first is commutativity. So you have done commutativity in mathematics. When two numbers are said to be commutative, we say that whole numbers are commutative in addition, natural numbers are commutative in addition. We have done this. Rational numbers are commutative in addition. So what is commutativity? A plus B is equal to B plus A. So for vectors, we can apply this law, commutative law. So if we have two vectors, vector P and vector Q, and we are adding these two vectors, so vector P plus Q is equal to vector Q plus P. Whether we add Q to P or we add P to Q, hardly makes any difference. So vector P plus vector Q is equal to vector Q plus vector P. Please comment. No problem. So let's verify this law with the help of an example. Let's see triangle law now. See, if we have vector P and vector Q, closer to okay. So these are two vectors. Okay, vector P and vector Q. So if we have to draw the resultant vector, then how do we draw? We draw like this. So this vector represents vector P plus vector Q. Triangle lo kya hota hai? Karan, Harsh.
Point of second vector पे ending vector ये resultant vector तो equal होता है
हाँ तो वो vector P plus Q होता है statement learn कर लेना इसका ठीक है एग्जाम में आती है okay so what if we have vector Q and vector P again we can add this like this okay so it's vector Q this vector is the resultant vector it is vector Q plus vector P right now you can see both the vectors are same. They are coinciding. Vector Q plus P and vector P plus Q both are represented by the same vector. So they are equal. Okay, so this is commutative law. Second is associative law. What is associative law? Associativity. Suppose we have three, if we take three numbers, in mathematics we take numbers A, B and C. So if we had B and C together and then we had A or we had B and A and B first and then we add C. So doesn't make any difference. We get the same answer. So here also we can apply this associative law. So if for three vectors A, B and C, if we add vector A and B first and then we add C to it, or we add B and C first and or later we add A, then they all are they are equal. We get the same resultant. So let's verify this graphically. Let's use the triangle law again. So we have these two vectors, vector A and vector B. So this represents vector A plus B. This is the resultant vector of these two vectors, right? Similarly, if we have vector C and we are adding this vector C to vector A plus B, again, we can get the resultant using polygon law of vector addition. We know that. Okay. So the resultant vector will be this. It starts from the starting point of A plus B and ends at the ending point of C. This is the resultant vector. It's A plus B plus C. Clear? Similarly, if we take B and C first, so we have vector B and vector C. Look at the vectors. We are not changing the direction of vectors. If vector B is pointing in upward direction, then in the second case also we are taking the same direction of vector B. If vector C is pointing towards this direction, then in the second case also we are not changing the direction of vector C, we are keeping the direction same. Okay, then this represents B plus C. This is the resultant vector. Now if we add vector A to it, then the resultant is the same vector. It starts from the starting point of A and ends at the ending point of B plus C, and this is the resultant vector. So you can see in both the cases we are getting the same vector R. Vector R will not change. How do we add the vectors which are pointing in different directions? If they are in the same straight line, but they are pointing in different direction, one vector is pointing in, yes, we write A plus minus B. We take minus of vector B, right? This is what we do. So in the same way, we do subtraction of vectors. Subtraction of vectors can be done. So if we have two vectors, vector P and Q, and then how do we subtract them? In the process of subtracting one vector from another, it is equivalent to adding the negative vector to the first vector. If for two vectors, vector P and vector Q, if you want to subtract these two vectors, vector P minus vector Q करना है अगर आपने, so we can write vector P plus minus of vector Q. ठीक है, तो यहाँ पे हमने क्या किया, we had taken negative of the second vector. Will change the direction of the second vector. See, in this way, we are not changing the magnitude of the second vector. Magnitude of vector Q remains the same. We are only changing the direction of the second vector. Clear? So let this vector be vector P, and we have another vector, vector minus Q. Okay. अब ये क्या है? देखो. If this is vector minus Q, then what would be the direction of plus Q? इसके opposite, 180 degree पे इसके opposite, right? Yes. ठीक है. If this is vector minus Q, then plus Q will point in the direction opposite to it. So you have two vectors here, vector P and vector Q. Let the angle between these two vectors be theta. So if the angle between vector P and vector Q is theta, then what is the angle between P and minus Q? Okay, before this, tell me that what is the angle between vector Q and vector minus Q? It's 180 because they're pointing in opposite direction. So if vector Q is pointing in this direction, minus Q will point in that direction. Angle between both the vectors is 180 degree. तो अगर vector P यहाँ है, ठीक है, और vector Q यहाँ है, and angle between both the vectors is theta. तो P और minus Q में angle क्या होगा, ये बताना है. 180 minus theta. Any doubt in this? है तो पूछ सकते हो, कोई प्रॉब्लम नहीं है. P और Q में अगर एंगल थीटा है तो P और माइनस Q में 180 माइनस थीटा होगा. यस, बिकॉज Q और माइनस Q में 180 डिग्री एंगल है. तो ये जो रिप्रेजेंट करता है, ये जो एरो है, ये वाला, लुक एट दिस वेक्टर. व्हाट डज दिस वेक्टर रिप्रेजेंट? व्हाट डज दिस वेक्टर रिप्रेजेंट? Between vector P and vector minus Q, we have another vector. So which law we have applied here? These two vectors have the same initial point. They are co-initial vectors. Vector P and minus vector Q are co-initial vectors. They have the same starting point. So when two vectors have the same starting point and we want to find the resultant of the vectors, then which law do we apply? Triangle law, parallelogram law of vector addition. We apply parallelogram law of vector addition. So here we have applied the same parallelogram law of vector addition, and it says that if two vectors are like the sides, adjacent sides of a parallelogram, then resultant of both the vectors is represented by the diagonal of the parallelogram. Okay, so here this vector S represents the diagonal. It is like the diagonal of the parallelogram. Okay, and diagonal of the parallelogram is the resultant vector. So vector P and vector minus Q we have. So vector S would be P minus Q. ठीक है? It is vector P minus vector Q. तो ये वेक्टर ऐसा आ जाएगा. कुछ डाउट है इसमें? कल ही करवाया था पैरेललोग्राम लॉ, कल परसों. हाँ, तो अगर ये वेक्टर P है और ये वेक्टर Q है, then how do we represent the resultant vector? These two vectors are like the sides of adjacent sides of a parallelogram. Then we can draw a resultant vector like this. And this vector R is equal to vector P plus vector Q. Now we have drawn one more vector, and that vector is the negative of vector Q. So negative of vector Q will lie in this direction. Okay, again we have two vectors, vector P and vector minus Q, and they are like the adjacent sides of a parallelogram. So we can draw a parallelogram like this. Okay, so we can also draw the resultant vector of these two vectors. And how will we draw the resultant vector? From this vertex to this vertex. So this represents the resultant vector. And what do we do when we take a resultant vector? We simply add the vectors, right? As here vector R is vector P plus Q. So we are taking the resultant vector as vector s this time. तो वेक्टर एस क्या होगा? तो वेक्टर पी होगा, बट यहाँ पे we do not have this plus q, rather we have minus q. So instead of writing plus q, we'll write minus q. क्या फर्क पड़ता है उससे? So we can write like this, or we can write vector p minus vector q. ठीक है, क्लियर है? So if the angle between these two vectors, vector p and vector q is theta, ये बात हो रही थी ना, थीटा वाला 180 माइनस थीटा. अगर ये आपका थीटा एंगल है और ये पूरा एंगल कितना है, दिस इज 180 डिग्री, है ना, तो ये कितना होगा, 180 minus theta. So you can also write the expression for, as you had written for magnitude and direction, आपने इसका resultant vector का find किया था, in the same way you can write for s. But for this case, we will take the angle as 180 degree minus theta, not theta, because this time angle between the two vectors, vector p and minus vector q, is not theta, rather it's 180 minus theta. So wherever we have theta, we'll write 180 minus theta. ठीक है, तो बेसिक रूल्स आपको ट्रिग्नोमेट्री के इसके लिए आने चाहिए, ओनली देन यू कैन अप्लाई. उसके लिए क्या होता है, आफ्टर स्कूल टू कॉलेज, पता है ना, आफ्टर स्कूल टू कॉलेज, साइन 180 माइनस थीटा इज साइन थीटा, कॉस 180 माइनस थीटा इज, सॉरी, कॉस 180 माइनस थीटा इज माइनस कॉस थीटा, टेन 180 माइनस थीटा इज माइनस टेन थीटा. बेसिक रूल्स आपको पता होने चाहिए. ठीक है, प्लीज राइट दिस. S is square root of p square plus q square minus 2pq cos theta. And similarly, we can write the direction. We can find the direction. How do we write direction? It's q sine theta upon p plus q cos theta. This we had done in the previous class. So q sine theta, in place of sine theta, now we are writing 180 degree minus theta, and for cos theta, we are writing cos 180 degree minus theta. Sine 180 minus theta is sine theta, and cos 180 minus theta becomes minus cos theta. So we can write an alpha as q sine theta upon p minus q cos theta. Okay, write this. हो जाएगा, इजी है, अभी किया ही हुआ है. एडिशन ऑफ वेक्टर्स, ट्रायंगल लॉ ऑफ वेक्टर एडिशन में और पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन में हमने मैग्नीट्यूड का, रिजल्टेंट वेक्टर का मैग्नीट्यूड और डायरेक्शन का एक्सप्रेशन फाइंड किया था. उसी एक्सप्रेशन में आपने चेंज किया अगर आपके पास एक नेगेटिव वेक्टर है. ठीक है, the vector subtraction does not follow commutative law. So vector p minus vector q is not equal to vector q minus vector p. But मॉड्यूलस जो होता है इनका, जो मैग्नीट्यूड होता है, जो उसका मॉड्यूलस लेते हो वो इक्वल होता है. मॉड्यूलस इक्वल क्यों होता है, बताओ, कैन यू एक्सप्लेन दिस, प्रूव कर सकते हो? Similarly, vector subtraction does not follow associative law. Can you prove this? Can you prove this? Let's consider two vectors. Let vector p is equal to, बताओ, xi ले लेते हैं, xi plus yj, and vector q is ai plus bj. First subtract q from p. So vector p minus vector q is x minus a I cap plus y minus b j cap. Similarly, we can write for vector q and vector p from q is a minus x I cap plus b minus y j cap. Clear? If we take modulus of p minus q for a vector, how do we write magnitude of a vector? If we have a vector a and it is equal to, let's say 2i plus 3j, then how do we write magnitude of vector a? करवाया था ना फर्स्ट क्लास में, square root of 2 square plus 3 square. This is how we write. So here also, If you want to write magnitude of vector p minus q, then how will we write? Square root of x minus a whole square plus y minus b whole square. And vector q minus vector p is again square root of a minus x whole square plus b minus y whole square. क्या डिफरेंस है? क्या डिफरेंस है? अप्लाई ए माइनस बी होल स्क्वायर इनपुट, यहाँ पे भी आपको यही मिलने वाला है एक्स स्क्वायर प्लस ए स्क्वायर माइनस 2ax. Here also you'll get the same terms, a square plus x square minus 2ax. Is there any difference? No. So if we are considering magnitudes only, then magnitudes are equal, but vectors are not equal. See, vectors are not equal. You can see it's x minus a and a minus x. Here we have y minus b, here we have b minus y. Vectors are not equal. But if you are taking the magnitudes of vectors, then magnitudes will be equal. Clear? Any doubt? Please write this. Draw vector, vector A. What if I multiply this vector by 2? Then? If I multiply this vector by 2, then we'll get 2a vector. 2a vector, right? So length of the vector will increase. Or we can say length means magnitude. So magnitude of a vector is represented by its length. Length will increase means magnitude of the vector will increase if we multiply a vector by a factor of 2. If I multiply this vector by 3, then 3 times हो जाएगी. Yes. If we multiply this vector by 3, तो length कैसे increase हो जाएगी उसकी? 3 times हो जाएगी. Suppose this vector A is I cap plus 2j. Then what is the value of vector 2a? 2 into I cap plus 2j. Or we can write 2i cap plus 4j. And if we multiply this vector by 3, then 3a vector is equal to 3 into I cap plus 2j. So this is 3i cap plus 6j cap. Right? And if we multiply this vector by minus 1, then what? Then? Then direction of the vector will change. But length of the vector remains. There will be no change in the length of the vector, only direction will change. So this time we can write vector A as minus vector A. Now it is minus vector A. So we will write this as minus I cap plus 2j cap, or we can write minus I cap minus 2j cap. Clear? What if I multiply this vector by minus 2a? Magnitude double हो जाएगा and direction will change. Direction of the vector will change or magnitude double हो जाएगा. So this vector is minus 2. This time we are multiplying this vector by minus 2. So we'll get minus 2a vector, and we can write this as minus 2 in the bracket I cap plus 2j cap. This is minus 2i cap minus 2 to the 4, 4j cap. Yes? Clear? Okay. What if I divide this time this vector by 2? Then length of the arrow will decrease. Length of the arrow will decrease. So this vector is vector A by 2. And we can write this vector as vector A by 2 is equal to I cap by 2 plus j cap. We can write half I cap plus j cap, right? So direction is not changing, only the magnitude is changing in this case. And what if we divide this vector by minus by minus 3? Then yes, so it will get minus 1 by 3a. अब क्या होगा? Direction will change और length कितनी shorten होगी? It's 1/3 of the length of given vector. Yes. So now we can write minus 1 by 3 I cap plus 2 j cap, or we can write minus 1 by 3 I cap minus 2 by 3 j cap. क्लियर है? बहुत बेसिक सी चीज है, बार बार पता नहीं क्यों इतने एग्जाम्पल से हम सॉल्व कर रहे हैं. आ गया होगा अच्छे से, है ना? जिसको नहीं आना है उसको भी आ जाएगा, राइट? Okay, so from here we conclude that if we have a number which is greater than 0 and we are multiplying that number by a vector, then magnitude of the vector becomes lambda times the given magnitude, and direction of the vector does not change at all, it remains the same, है ना? तो अगर हम किसी वेक्टर को लैम्डा से मल्टीप्लाई कर रहे हैं तो, और वो लैम्डा ग्रेटर देन 0 है, ग्रेटर देन 0 का मतलब क्या है कि मैग्नीट्यूड इज इंक्रीजिंग, लैम्डा ग्रेटर देन 0 है, तब उस केस में मैग्नीट्यूड इंक्रीज हो जाएगा, बट देयर इज नो चेंज इन द डायरेक्शन ऑफ द वेक्टर, बिकॉज़ यूनिट वेक्टर विल पॉइंट इन द सेम डायरेक्शन. क्लियर? And if we are multiplying a vector by a number which is less than 0, so here lambda is less than 0 means we have minus lambda, then magnitude becomes negative of the given magnitude and direction. See, magnitude becomes lambda times, but direction changes because we have a negative sign here. Okay, so magnitude becomes lambda times, but direction changes. We get this. So this is minus lambda vector A. I hope this is clear. If lambda is a scalar quantity. And we are multiplying a scalar quantity by a vector. Okay, we have a vector A, and we are multiplying the scalar quantity by a vector. So if we multiply a scalar quantity by a vector, then we get another vector, vector B. Okay, so this is another physical quantity. Another physical quantity. It may have different dimension. But direction same है, ठीक है, but same direction. Can you give any example of a scalar multiplied by vector? Any example? कुछ आ रहा है याद? अरे क्या कर रहे हो? Yes, force. In work, we have two vector quantities that there we take dot product, cannot consider. But force is mass into acceleration, and displacement. Displacement is velocity into time. Yes. Velocity is displacement upon time. एक ही बात है. Acceleration velocity vector dv vector होता है ना upon dt होता है velocity upon time. So here mass is scalar quantity. Yes. Momentum. Now you know. आ रहे हैं ना? Momentum, mass into velocity. So mass is a scalar quantity. Time is also a scalar quantity. So here we are multiplying a vector quantity with a scalar quantity. I'm getting another vector quantity. So you can see that acceleration is one vector quantity. And when we multiply this acceleration by mass, which is a scalar quantity, then we get force, a vector quantity, which is entirely different from acceleration.